let's look at the kind of risk we take when we do a hypothesis test. We talk about a lot of these things all the time, alpha risk and beta risk, but what exactly does it all mean? So the first thing is you've got to have a null hypothesis. We always have a null hypothesis as we go into our experimentation. So if I were to think of it as a decision tree, one opportunity is for my null to be true. Okay? If my null hypothesis is true, I certainly don't want to reject it as I go through. The other alternative is that my null hypothesis might not be true. Okay, in which case my hope obviously is to reject that hypothesis as we go. So one of the options I have for doing anything in my experimentation is to reject the null hypothesis. That's obviously going to happen, a great deal of the time if the null hypothesis is wrong. But otherwise, I run the risk that I will fail to reject, or not reject, I should say, because sometimes that's the exact outcome I want. So if I think of this as a continuum, I basically have a decision quadrants that I can speak in terms of. Now, in terms of what I want to have happen when I'm running a hypothesis test, is if the null hypothesis is not true, I want to reject it. So this is my favorable outcome right here. I want this to happen. Or, if my null hypothesis is true, I want to not reject the null hypothesis. So these are the two quadrants we want to be in as we go through. So if this is a jurisprudence type of application, here I want to convict the guilty, right? Okay, so if the null hypothesis is that the person on trial in a criminal trial is not guilty until proven so, we want to convict guilty people if in fact that null hypothesis is true. Otherwise, we'd like to acquit the innocent. Okay, the null hypothesis is that someone is innocent, so we want to stick with that and not reject it if in fact they are innocent. Likewise, if someone walks into a hospital, the null hypothesis is that they need treatment. So we want to treat the sick if it turns out that they are, in fact, sick as they come through. But otherwise, we want to send the healthy home. Okay. So those are two kinds of activities we can do that are in the appropriate quadrant where we either accept or reject the null hypothesis going through. Then we get into these other two quadrants where a lot more is happening. Over here we have our type 1 error, what we refer to as type 1, or our alpha risk. This is a case where the null hypothesis is true, but we, for some reason, reject that null hypothesis. In the lower quadrant, we have our type 2 error, okay, which is known as our beta risk. In our beta risk, we basically fail to reject the null hypothesis, even when it's not true. So we don't want to be in either one of these quadrants, and which is wrong is a problem. So up here in this corner, we might convict the innocent. Okay, we reject the null hypothesis that the defendant is not guilty, and we accidentally convict an innocent person. In the lower corner, we could potentially acquit a guilty person. That would be bad. If we fail to reject the null hypothesis that they are innocent, we could let a guilty person go free. Likewise, we could tell a healthy person that they're sick. Okay, so that's the case where that would not be a good thing. If you're a perfectly healthy person, you don't want to be told you're sick. But likewise, we could tell a sick person that they're healthy. Okay? So here we call this the false positive, and down here we call it the false negative. So a false negative is the beta risk, and a false positive is our topic. So we don't want risk in these two categories, but which is good and which is bad is very, very highly contextual. You can't really say, because the reality is that we don't want to convict the innocent. Okay? This would be a serious problem. So typically, we accept the beta risk of acquitting the guilty. So our jurisprudence system is set up on the notion that it's better to let some guilty people go free than to accidentally put someone in prison who doesn't belong in prison. So alpha risk is considered the bigger problem. We would want to tighten up and have a very, very tight control on alpha risk. As you can see in our court system, it's very, very difficult to convict someone, as it should be. But on the healthcare side, it's kind of the opposite. We really don't want to tell a healthy person that they're sick. If I do a test on you for some disease, maybe I'll do a mammogram to determine if you have breast cancer. I don't want to tell you you don't have breast cancer if in fact you do, because I misread the test or we made a mistake in the test. A false negative test in healthcare is considered very, very bad. You might go home and not see a doctor again for years. So we don't want this outcome to happen in healthcare. So typically we accept the alpha risk that a healthy person should be told that they're sick. It's better to do a test and get a false positive and take a closer look at a patient than to send them home thinking they're not sick. So look what's happened in these two quadrants. Which type of risk you want to take is very, very dependent upon the application that you're working in and what you're trying to do. If you're running a court system, you want to minimize your alpha risk, even at the risk of sending away some guilty people and letting them go free. If you're running a healthcare system, you need to manage your beta risk to make sure that everybody that might be sick gets more and more testing until you're absolutely sure, that you don't accidentally send someone home thinking they're not sick when in fact they might be very, very ill and be in real trouble because you've sent them home. So alpha risk, beta risk, neither of them by themselves can be said that's the one we're trying to avoid. You've got to look at your engineering situation, you've got to look at your industrial engineering situation and decide which of these risks am I trying to manage. And so, very often you need to minimize one at the expense of the other. Once in a while you need to optimize and really find a way to minimize both at the same time. It's one of the reasons we go with different alpha levels on our experimentation. Because you don't typically pick the beta level, you pick the alpha level you're going to be playing with. You will have some control through your sample size when you do your statistics on where the beta level falls out. But the only real choice you have here is you'll pick the alpha factor when you're looking at your hypotheses.